Hi, my name is Sir Arthur Eddington, and I was a member of the solar eclipse project that occurred on May 29th, 1919. The goal of this project specifically was to figure out how much light reflects, bends around a celestial mass, because there were two different theories out at the time. There was the theory of Isaac Newton, and there was also the theory of Albert Einstein. Isaac Newton theorized that the amount of light that bent or reflected, however you would like to say it, was about half of what Albert Einstein predicted. And so the goal of this experiment project was to figure out how much light is actually reflected. The project actually occurred in two different places, in a manner of speaking. There was only one solar eclipse, however, we sent teams to two separate places. The one place that one team was sent was to Sobral, Brazil, and the other team was sent to Principe, which is an island just off the coast of West Africa. I was personally with the team that went to Principe. The Brazil team was almost a backup just in case something went wrong in Principe and we couldn't get accurate measurements. Say it was raining, it was cloudy, we couldn't actually see the solar eclipse. So we sent a backup team to Brazil, but it ended up working out for us. We got a clear sky. We were very worried because it was cloudy that day, but we ended up being able to see what we needed to see. Also at this time, the thing that made this project happening a little bit of a problem almost was that World War I was occurring. Obviously, when there's a war going on, countries need all their supplies to go to their troops, war, everything. So they didn't have the supplies to just give us ships, to just give us telescopes, that kind of stuff. And so we were very worried that this wasn't going to be able to occur in time because we didn't know when World War I was going to end. But luckily, World War I ended in November of 1918, and so we had plenty of time, in a manner of speaking. We had about 5 months, which is a little bit of a time crunch, but we had thought of this project way in advance, and so that kind of gave us the ability to plan for it in enough time to where we could get ready. And then once we got the go, essentially, we were like, okay, this is what we need, and get all of the stuff done. There were a couple other people involved in this project. Sir Frank W. Dyson was the man who thought of this, who came up with the idea to set sail to go view the solar eclipse to prove which theory is right, Isaac Newton's or Albert Einstein's. And then also we had our teams. Like I said, we had that one team in Brazil that got sent there, and they had to go in the very hot heat where it even warped their telescopes. It was so hot. And then we also had the team in Brazil, or not in Brazil, I should say, in Principe off the coast of West Africa. And so there are a couple different people involved, but Sir Frank W. Dyson was one of the major people, just because if he hadn't thought of this idea, this may have never occurred, and it may have been many years, and I may not have ever been involved on this project. So because he thought of it, we were able to get this done and get an accurate measurement and figure out which person is correct. And so my role within this whole solar eclipse project was to be the team leader, almost. Sir Frank W. Dyson thought of it, and then got the funding, got the supplies, and then was like, here, you take it over. And it kind of became my project, my baby. And so I took it from then on out. I was the one who kind of was like, okay, we do need a second ship to go to Brazil, because you don't know, the weather may be bad. And so I was the one who kind of got the team ready, formed the teams, got everyone ready before they knew it. And so we were very good. It was awesome. We got set sail. And then I also measured before the solar eclipse. So in February of 1919, I was already on the island of Principe. I took measurements of the star before the solar eclipse occurred. And the reason I did this is so we could compare the measurements from when the solar eclipse occurred to before the solar eclipse occurred, so that we could compare them and see what the difference is, because this is what was going to tell us how much light was reflected or bent. This was what was going to tell us who was right, who was wrong. So this was super important. And so I ended up doing it myself just because I wanted the most accurate and precise measurements possible. And this is what I had been passionate about for a very long time. And so this project ended up being very impactful on the physics community. Our results ended up proving that Albert Einstein's theory was correct instead of Isaac Newton. There was a lot of pushback at the time just because Albert Einstein was a German scientist. World War I, we were going against the Germans. People were taught not to trust the Germans. And so people didn't want to believe his theories. And so this kind of helped to prove him right, and Isaac Newton, not necessarily wrong, just inaccurate. And so this helped to expand the thinking, because now we did have a measurement of how much light was reflected or bent, whereas before we were very iffy if we were going to even be able to do it. And that was one of the reasons we also had pushback in the community after this project was done. They didn't know if we were going to be able to get accurate enough images to actually measure it. And also, a lot of people thought that I was biased in my experiment, because we did throw out the Brazil team's data, which did lean more towards Isaac Newton, because their telescopes were warped from the heat, and they had to use, I believe it was 10 centimeter long telescopes, and so those may not have actually given us the most accurate picture we could have. And so we threw those out and only went with the measurements we found from Principe, and ended up being within 2 standard deviations of Albert Einstein's amount. And so once we did that, once we got through the pushback, another experiment was performed, the same one, just by different people, in 1922, and they found out that we were right the whole time. Albert Einstein's numbers are the closest, and the more and more experiments that were done, the more people found out that Albert Einstein was correct. And so this also kind of helped to propel Albert Einstein into notoriety, into being a renowned scientist, because people were like, okay, we know who this man is, he's right, he's accurate, and there are measurements and experiments to prove it. So by the 1960s or so, it was fully accepted of Albert Einstein's theory of about how much light is reflected or bent around celestial bodies. And so one question I get asked a lot is, who was my biggest inspiration growing up? And that would be Albert Einstein. He wasn't necessarily famous when I was growing up. When I was growing up, I was always interested in the stars. I always loved just looking out, counting them, that kind of stuff. And so as I got older, I strayed away from it. I went more towards mathematics, that kind of thing. But then eventually I was like, okay, here we go. And I got a job working as an astronomer, and it led me to this project. And the time I got into astronomy again, Albert Einstein had just come out with his theory of relativity, which I was astounded by because it was so amazing. And so I was pretty impressed by his work, and he is one of the reasons that I felt the need to go on this voyage and to do it, because I saw how great of a physics individual he was, and how great of a scientist he was, and how he was getting backlash because he was German in World War One. And so that was one reason that I really felt the need to do this project, was because I felt he was accurate. Was I biased going into this? No. If Isaac Newton was correct, I was going to believe Isaac Newton was correct. However, the data pointed us that Albert Einstein was correct. So he genuinely was probably one of the greatest people that had an impact on my career and my goals in astronomy, in math, as I was a big mathematics person, and in physics in general. But thank you guys so much for asking me about this solar eclipse project. It was a pleasure talking to you guys today. So thank you.